Today we're going to be looking at calculating arc length and sect area. The booklet on showing homework matches the examples that we're going to be looking at on here. So you might want to print out a pen and paper will be fine though. You might also need a calculator. I'll pause a moment for you to get what you might need and pause the video, and then we'll get started. Okay, so in order to calculate arc length and sector area, we need to be able to compare the area of a circle. So the circumference is pi times diameter, and the area is pi times radius squared. So the diameter is from one edge to the centre to the other edge, and the radius from the centre to the edge. So here we've already got a radius. For this example, the diameter is all the way across, so it would double the radius, so it would be 8. So the circumference is pi times 8, area is pi times 4 squared. If you put those in your calculator, pi times 8 gives you 25.1 centimetres to 1 decimal place. The area, pi times 4 squared, gives you 50.3 centimetres squared to 1 decimal place. And don't forget units for area here, centimetres squared. Arc length is a portion of the circumference, which is why we need the circumference formula. And the sector area is a portion of area y. We need to be able to calculate area of the circle. Going with area, and then we can move on to arc lengths. So here we've got a couple of special examples which we're then going to be able to use to apply to find the sector areas. So here, if we imagine there's a full circle, we're going to calculate the area of that first. So formula, pi times radius squared. The radius here is 5, so pi times 5 squared, which we're going to calculate, gives you 5 pi. I'm going to leave it like that because I haven't quite finished the question and I don't want to let any exactness. Here we've got the full circle. We want just half of the circle. So we want half of the area of the full circle. Half multiplied by the area of the full circle, which when we put that in a calculator, we get 39.3 centimetres squared. And I've rounded that to 1 decimal place. If we look at the example on the right, we're going to do the same thing. We're going to find a circle and we're going to find the area in proportion of the full circle. So the full circle here, we've got the radius being 8 centimetres, so we're going to swap that in. Pi times 8 squared, which is 64 pi 10. I'm going to do anything with that. I haven't quite finished the example yet. I need to find the proportion of all circles. So this is a quarter circle. So I want a quarter of the full circle. I want a quarter multiplied by the area of the full circle, which when I put that in my calculator is 50.3 centimetres squared to 1 decimal place. We've then got another example here, and again we're going to find the area. So pi times r squared. Imagine the full circle was there, the radius would be 4 centimetres. Pi times 4 squared, which is 16 pi. We're going to leave it like that because we haven't quite finished with it. And then this circle is 3/4 of the full circle. The proportion is 3/4. I want 3/4 of the full circle, 3/4 multiplied by the circle is 37.7 centimetres squared to 1 decimal place. Then we've got a slightly harder example where we can't immediately see the proportion of the circle that we need for. So to begin with, we're just going to focus on the area of the full circle like we had previously. We're going to divide times the radius 10 squared. And the proportion of the circle here is the proportion of the full circle. So we know that there's 125 degrees. We know that in a full turn it's 360 degrees. So the proportion of the circle in this case is 225 out of 360. And then we're going to multiply that by the area of the full circle, which is pi times z squared in this case. I'm going to find my calculator just as it is there, and 196.4 meters squared to 1 decimal place. Now I'm going to use this to find a general rule for the area of the sector. So remember, every time we calculated the area of the circle, so pi times radius squared, and then we wanted a proportion of the circle as a sector. So here, the angle out of 360 is the proportion of the circle that we would be using in the sector. Here, it's just called a Greek letter theta, and that's what we normally use for angles. So we've got theta over 360 times pi times pi the radius squared, and this is the general form of area of the sector. So full circle and the proportion of the circle we want. Now we're going to move on to arc length. So because we're talking about arc here, which is part of the circumference, we're not using the area formula now. We're going to be using the circumference form, which is pi times theta. Here, this line is half of full circumference. So we're going to find the area of the circumference of the full circle. The diameter is 10, it's all the way across. So 10 pi, and again, I haven't quite finished with it, so I'm going to leave it like that. And then I want half of full circumference. So half of the full circumference, which is 15.7 centimetres. And we're talking about a length here, so there's no squared on it. Then got a second example, circumference of the full circle. So if you have full circles there, pi times diameter would be all the way across. So it would be 2 lots of 8, so it would be pi times 16, or 16 pi. Again, I haven't quite finished with it, so I'm going to use the decimal. I'm going to use this to keep the exactness. And then because it's a quarter of the circle, I'm going to do a quarter of the circumference of the full circle. Put in my calculator, and I get 12.6 centimetres to 1 decimal place. And I've got another example here, and we're going to calculate the area of the circumference of the full circle. So if we imagine the full circle being there, the diameter would be all the way across, so it would be 42 lots, so it would be 8, so it would be pi times 8. And then, because we've got 3/4 of a circle here, we want 3/4 of the circumference of the full circle. Put that in your calculator, 18.8 centimetres to 1 decimal place. We're then going to use what was learned to apply this to a slightly higher example. Again, we're going to do what we did before, calculate the area of the circle, which is the circumference of the circle, which is pi times the diameter, which is all the way across, pi 20. And then, because we're looking for the proportion of the full circle, we're going to do the proportion of the full circle multiplied by 20 pi. Remember, as in the sector area, the proportion of the full circle will be 225 in the example out of 360 multiplied by 20 pi. I'm then going to put that in my calculator, and I'm going to get 39.3 centimetres to 1 decimal place. We've then got the perimeter of the shape. So this arc length is only the red bit. if it asked you for the perimeter of the shape and not just the arc length, that would mean you would also need these two lengths to add on as well. Okay, so we'd add on two radiuses, so a 10 and a 10. So just be careful. If it's arc length, that's as far as you need to go in the question. But if it asks for perimeter, you also need these two lengths here added on, which is 59.3. We're now going to make a general rule like we have before. So again, arc length, remember we've always used pi times diameter, and then we want the proportion of the full circle. So we want the angle out of 360, which here we use angles generally in maths to be as the letter theta. So it's theta out of 360 times pi times the diameter. And the perimeter of the shape is the angle out of 360 times pi times the diameter. So it's the arc length plus 2 lots of the radius. So we've got a couple of examples now where we're going to go backwards. So here we know the arc length and we want to know the angle at the centre. Okay, so because it's asking us, because we know the arc length, it's the arc length formula that we're going to use. So remember from just a minute ago, the arc length is the angle, or theta over 360, times pi times the diameter. So what I've done here is I've swapped in the things that I know. So I know here that my arc length is 33.5. I've got my radius, which is 12. So my diameter, which is all the way across, must be 24. So I've swapped in what I know. I've then thought about this pi times 24 as 24 pi. And it's multiplied here. So to move it to the other side, I'm going to divide. So I've divided by 24 pi. And the reason I've done that is I'm trying to move everything from this side over to the other side. So I've got theta, or the angle, on its own. And then if we look here, the only thing that's on the right-hand side that isn't the theta or the angle, because that's what we're trying to find out, the angle at the centre, is the divider by 360. So when it moves to the other side, it becomes a multiply. So we're going to multiply by 360 to give us theta. I'm going to pop that all in my calculator. And I'm going to get 160.0 degrees to 1 decimal place. Okay, so another example. We're going backwards when we know the area. What is the length of the radius? So because we know the area, what we're going to do is we're going to use the sector area formula, the general formula. So remember, sector area, angle over 360 times pi times the radius squared. I'm going to swap in what I know, and then I'm going to start to rearrange to find what my radius is. So my sector area is 150 and my angle is 200. So I've swapped in what I know. Then to move this divided by 360, I'm going to multiply it on the other side, and I can do that because the links between everything, there's no addition or subtraction there, it's only multiply. So there's only a multiply or a divide. So I'm going to multiply by 360, and I've brought those two together as 200 pi to make it easier when we're then going to move that. Okay, so here the link now is multiply. So to move it to the other side, I'm going to divide by 200 pi. I'm going to pop that in my calculator exactly as it is there, and that gives me my radius squared. I'm not quite there because it's not asking for the radius squared, it's asking for the radius. So the opposite of squaring is square rooting. So I'm going to square root this 85.943 to give me my radius, which is 9.3 centimetres to 1 decimal place. So here, another exam style question. These two sectors have got the same area. What's the angle missing? So on the right hand side, we've got an angle here that we don't know, and we're going to try and find what it is. So we know that both of these have the same area. So what we're going to do is we're going to use the sector area formula to help us out. So I know that this one here has the same area as this one here. So I know they're equal to one another. So I'm going to swap in on the left-hand side. I'm going to concentrate on this side first, and then I'm going to use this in a minute to calculate the area of the left-hand side. So I've got 72, the angle, out of 360 times pi times 6 squared. And then on the right-hand side, the angle I don't know yet, divided by 360 times pi times the radius squared, which is 12 squared. Then I'm going to work out an answer here. I've worked out an answer, and I'm going to leave that in my calculator so that I don't make any rounding errors. I know that 12 squared is 144, so I've made that pi times 12 squared is 144 pi, just to help me out a little bit. Okay. Then my aim is to move everything from the right-hand side that isn't the angle part, the theta part, over onto the left, so I know what my missing angle is. Okay. So I'm going to divide by 144 pi because it's a multiply here. And then, because the only thing on this side I'm left with is a divide by 360, I'm going to multiply by 360. And that will give me the angle, and the angle is 18 degrees. This should help you with the work that's been set on arc length and sector area. And don't forget, the arc length formula is the angle over 360 times pi times diameter, and the sector area formula is the angle over 360 times pi times the radius squared. I hope this helps, and if you need any help with anything, please let me know. Thank you.